All right, so we're going to start going in under the Start menu and go under All Programs and look for ANSYS. And under that, or you can just search for it, but we're looking for this Mechanical APDL. And so find the Mechanical APDL and click on that. So this is going to diverge a little bit from the tutorial itself, but you get into the same program. And I haven't set this up yet, so I can allow access here. All right. So you should come into this screen. If you don't come into this screen, let's talk, because we'll need to fix it right away. Otherwise, you're going to be having. All right. So the first thing we want to do is name our job. So we'll go under File, and under Change Job Name, we'll change that to something like Truss. Whatever, you can call it whatever you want. And we'll hit OK there. And also go under File and change the title to Truss. All right, just gives us everything nicely labeled. All right, so what's nice about this, you're basically going to work down the left-hand side here in the main menu. So we'll start here in the Preferences. Now, typically you don't have to go in here. I'm going to show you what this does, and then I'll come back and change it back to neutral. But basically, if you're working in a specific area, what it'll do is it'll narrow down your choices only for that area. So if you're working in a structural area and I select that, I'll get only the structural options as I go along. So I'll show you that here. I'll check it now. You can check it or not, whatever you feel like. But I'll check it here and then I'll uncheck it the rest of the way once I show you how it's different. So hit OK there. All right. Under Preprocessor, so you can kind of think about this as the different steps as we go through the formulation. All right, so we're going to go through the Preprocessor. And we're going to define our element type. So when I'm expanding these, I'm clicking on the plus minus sign. And so the plus sign to expand it. Let me open up this menu a little bit too here. All right. So we're going to add the element that we're going to be working with. So click on Add, Edit, Delete. And so right now none's defined, so go into Add. And so right here we have structural mass and we have all these options here. We're going to be working with links today. That's like our truss, our two-force member. All right, so click on link. And as I said at the start, everything we're dealing with now is 180. So it says it's a 3D finite strain members, but we're going to use that one at 180. So if it's already selected, we can go ahead and click on OK. And it says that element 1 is going to be defined as link 180. All right, so go ahead and close on that. Now, I'm going to go back here. I said I'd show you what looks different. And actually, let me go back in here real quick. So we'll go Add. You don't have to follow this. But as we go through the menu, see how the options are? All right, gasket, cohesive, combination, structural mass. All right, let me go back here and change the preferences back to, show me everything. Yes. And I'll go back in here and add elements. So now I got structural, thermal, magnetic vector, magnetic, electrostatic circuit. So you can see how it narrows it down pretty quickly to stuff you're probably going to be useful to. All right. So I'll leave that open so you can see everything in case you forget to check in the future, but that's helpful along the way. All right, so we added our element, link 180. Now we're going to the next part, and we have our real constants. All right, so come down here to real constants, the next menu right after element type. So just working down the left-hand side. So go to Add, Edit, Delete there. And none defined, so we're going to add. And it quickly brings up our element that we've added. So if you have multiple elements, this is where you have to choose which one. We'll worry about that later, but for now we just have one. So we'll go ahead and OK. All right. So this is going to be real constant. Again, different constants have different numbers. So this one, you just go with the default, number 1. So what's the cross-sectional area? All right. What's the cross-sectional area of our members? 8 inches squared. So we're going to put an 8. But notice what it doesn't have. We put an 8, but it doesn't say units. So we need to be very, very, very careful with units here. You need to be consistent in your own head because this is very generic, but then you have to be careful with units on your own. All right, it's not going to spell them out for you. All right, so we got 8, and now we know that we're going to be using inches from here on out. So anywhere we see feet on this diagram, we have to convert that over. All right, so we have the 8. We'll go ahead and hit OK on that, and then close. All right. Again, working to the next one on the left-hand side, we'll go down to Material Properties. We'll click on that. And we'll go to Material Models. Right here in the middle. So click on Material Models. And I'll bring up your window here. So you can imagine if we would have selected structural back at the start, right, you basically just see this, right, not all these other ones. So click on structural, and we're going to make the material we're going to be working with is a linear material. So click on linear and linear elastic. Click on elastic, and it's going to be isotropic. Right, so click on that. So what it brings up here is it says, okay, what kind of material you got? You got, I need to know your modulus, and I need to know the Poisson's ratio. All right, so what's the modulus? 1.9 E6 to be the nice shorthand way you can put that in there. And for Poisson's ratio, Poisson's. Yeah, it doesn't say it there, but we're going to just use 0.3. It actually shouldn't use it in any of the calculations we're doing, but 0.3 is just a nice one you can throw in there. All right. So 1.9 E6, what's the units on that though? Okay, so we're okay there with the inches, so we just got to now reduce in pounds. Make sure we consistent there as well. All right, so 1.9 E6, and we got 0.3 there for Poisson's ratio. All right, so okay there. And though it feels weird, go ahead and close. There's no really OK button. If you go over here to material, you can exit, so either one's fine. Those are my papers that just fell off. Those following along in the video, papers fell off the table. There you go. That'll be fun later. All right. All right, so we got that. All right, so let's save DB. All right, you want to do a lot of save DB along the way because if it crashes, which it usually doesn't here, you'll have it saved. So you'll see plenty of save DBs along the way. DB has been interpreted by different classes in different ways, so it'll be interesting to hear what your interpretation of DB is. All right, so we'll go over here to work plane. All right, so we can see what we're going to be dealing with, or change it so we can see better. And we'll go to WP settings. All right, so this is going to basically change how it displays here in the middle. All right, so we're going to look at here, we got Cartesian, we're going to keep that. We want to see grid and triad. A few times I've seen people miss this change and they're like, wait, I can't see where I'm at or what I'm doing, and I don't see things, so make sure that's selected. Snap increment, we're going to change that. Basically, it's if we want to click on different points, it'll snap us to different locations. We're going to do 12 for 12 inches, all right, because we got a lot of feet going on in our model. Spacing, we're going to do 12 as well. We're going to do a minimum of 0 and a maximum of what? What do you think? 12 inches? 36, so 3 feet. Yeah, 72. We gotta get a grid that's gonna fit our whole drawing there. So we got 6 feet's our longest dimension. So it'll be 72 there. All right, go ahead and OK. All right, and then go back up to work plane. Can't see it, so we gotta display it. So display working plane. Where'd it go? All right. So you gotta make sure you can see it. So what you're gonna do is you're gonna zoom out. Right now you're zoomed in really far in one little box. So click on the zoom out button here, all right, a few times, like several times. All right, so you can see it coming there. And then you're going to use the pan buttons here just below the zoom out button. So you can pan left a little bit, and hopefully you can see the rest of them. I think I got to expand my menu here. Oh, no, it's up here, down, and then zoom back in again. And pan it back over. Try to get centered in as big as you can. Do one more here. Oops, wrong way. Okay. All right. All right, so now what we want to do is we want to create some nodes. All right, so we did the material model, we defined the material, we've defined the type of link we're dealing with trusses. So let's go down here to the preprocessor modeling, here on the left-hand side. So we'll click on modeling, and we want to create, so click on create. We want to create nodes. Click on nodes. All right, and we want to do it on the working plane. So we just created the working plane here, so we want to create those nodes on the working plane. We'll actually use one of these other ones later, but I'll show you that at that time. All right, so click on working plane. All right, we got this great little node picker. That's node, not nose, node picker. All right, so if we follow the way the nodes are labeled on the sheet, that'll help us with the numbering to be same as what we have on our handout there. So we're going to start out with the one there at the bottom left-hand corner because that's node number 1 on the sheet. So just click with that arrow pointing up like this. Click right on that corner there. All right, you can see count number 1, minimum 1. All right, all those things. All right, so that's 1. Now the spacing is what? What's the spacing on this grid? Foot. All right, 12 inches. So to get over to 2, where's 2 going to be? Center bottom. So 1, 2, 3 feet. All right, so the center at the bottom, that's going to be 2. So click there and we'll get number 2. Number 3 is 3 feet up from where we were at for number 1. So 1, 2, 3 feet. Click, and that'll be number 3. And then number 4, center, right? 3 feet to the right. 1, 2, 3 of node 3. So that's node 4 right here. And then we'll show you how to put numbers on these in a little bit, but here's just picking. And then number 5 is 3 feet to the right of that. 1, 2, 3. All right, so you should have those 5 there. All right, so we'll click on OK. And there are the numbers. Extremely small, but hey, there's numbers. All right, if you do this and you by chance put one in a location you realize is wrong, you have create, but you also have the delete option. So you can come in here and delete it, and then come back in and create it again. All right, so I'll let you play with that some later time. All right, so let's go up to the work plane. Again, the work plane menu at the top. And we're going to undisplay, or turn off the work plane, because now we have our points where we want them. We can see them a little bit better now. And we go under plot controls, just the menu just to the left of that. And go down to numbering. And what we're going to do here is we're going to turn on the node numbers. So, but you might be saying, hey, they're already on. Well, yes, they are, but once you refresh, right, if you ever do any changes, those numbers will disappear. All right, so we want to come in here to make sure they stay on. And, oops, let me go back up here. There we go. Yeah, if you want to play with this too, I can put some other numbers on there, but we'll just keep with that for now. All right, so click on OK. All right, so nothing should change because we'll just fix our numbers there. All right, and let's just check. Make sure we put our nodes in the right spot. All right, and sometimes you might have nodes that are hidden or on top of each other. We'll talk about that later as well. But you can come over here to list, and then down to nodes. All right, and we can look at the, we can change it just coordinate only because we don't really have any angles at this point. And click on OK, and it'll show us, all right, where the different nodes are based on the X, Y, and Z locations. All right, so we can double check ourselves to make sure they're in the spots where we want them to be. All right, so we got to close that. Save DB. All right, so we defined our element, or we've defined what kind of elements we're going to use. We've defined the material. We've put our nodes in the right spot. What are we missing? Elements. We got to put some elements in there. All right, so we're going to go back to modeling create where we were before, but instead of creating nodes, all right, we can minimize that. We're going to create elements. All right, create elements, which is right underneath it. All right, so modeling create elements. And this is going to be super easy because we're going to use the auto-numbered option. So click on auto-numbered, and it's going to be through nodes. So the nodes we just created, we're going to create elements through those nodes. So click there. All right, so we get the same picking window that we had before. All right, and order matters here. All right, so we want to pick node 1, and then node 2. And then you can do one of two things. You can go over here and apply, which I'll do this time. So you go ahead and do that this time. The other option you have is something else, which I'll show you here next. Let's go to node 2 and then node 3. So click node 2 and then node 3. And now instead of clicking apply, in the middle of the screen here, carefully push down on that scroll button for a middle click. All right, so now you don't have to come over here and click apply now. All right. Let's do 3 to 4. And now we know the middle click, which I think is a whole lot nicer and faster. Middle click for that one. We'll do 2 to 4. Middle click. 2 to 5. Middle click. And 4 to 5. Middle click. I don't believe so. Yeah, I think this one, it kind of neutralizes it, and it'll catch up for you. Yeah. That's a good question. You can unpick too. There's an unpick option up here. And the same deal here if you put an element in the wrong spot. And actually, I'll do it this time. I'll click OK to confirm all those. I'm going to go back here, and instead of create, I'm going to delete. I put in an element in the wrong spot. So element, delete element, and I'm going to come here and pick my element, the last one I put in, and click on OK. Doesn't look like looks like it's still there, right? But come up to plot and replot, and it's still gone. Haha. I need to plot my elements. There we go. All right, so that element's gone. All right, so what happened there is on the refresh, it didn't know to show the elements every time, so I had to come into plot and then elements to show them again. All right. So that one's gone, so that's how you can delete it. So I'll go back up in here and put it back there. So I got to create my element through node again. So 4, 5, middle click. All right, any questions there? All right, so we have that. Where are we at here? All right, save to be. Now what? We got our elements, we got our nodes, we got our material defined. What's next? What? You don't know? What haven't we even defined yet? Loads. You're cheating. You're looking at the book. Yeah, you look right here. That's right. All right, so we got modeling. All right, so now we're going to do is we're kind of cheat. We're going to go to solution. So you're not quite at the solution yet. You're not solving it, but it's kind of part of the solution. You can also go here, loads. That's in the preprocessor menu. I'm just going to follow the book so we're consistent, but it's going to be the same process between both those. So under solution, find define loads. And we want to apply loads. So we got solution, define loads, apply them. And guess which kind we're going to apply? Yep. What do you think we're going to apply? Force. On nodes. Okay. So we're going to pick, and where are we going to apply it? All right, so 4 and 5. In this case, they're both the same. If they're not the same, then you'll just have to pick one, apply it, give it a load, come back and do it the separate one for this. But this one we can do both 4 and 5 because they're the same. So click on both 4 and 5. All right, and then we'll hit OK. I'm sorry? That's the next one after you hit OK. Yep. So yeah, hit OK, and we're going to the direction of the force. And you're saying, well, which way is X? Which way is Y? Look at your triad here. All right, your triad says that Y is up and down, so we know we want Y. And also y is pointing in the positive direction. Right? Since our force is being applied downward, at least as our screen's orientated, we want to put a negative value there. So we'll put in a negative 500 pounds, because back when we did the modulus, we said we're doing PSI. So we know we're doing pounds here. What's that? Yeah, so then you do X component and then a Y component. All right, so click OK on that, and it gives you these pretty red arrows to indicate you have a load. All right, now we have the load applied. Anything else we need before we solve this puppy? Oh, boundary conditions. All right, so that's going to go up here to structural, and we're going to define, instead of force moment, we're going to find displacement. How far is it going to displace? All right, on nodes. All right, so we got nodes 1 and node 3. And again, in this case, they're both the same. If they're not both the same, then you do one and then the other. All right, middle click, or you can hit OK. Either one's fine. And these are actually fixed ones. It looks like a pin joint. We're going to call them fixed to be consistent with the book here. So you click all degrees of freedom. It's locked in all degrees of freedom, not moving in any direction. It's going to be 0. All right, so click on OK there. I give you this nice little blue arrows that say this guy's not moving. All right, we're good there? All right, anything else? Save DB. Anything else? Did we define all the loads? We fixed it. We got loads applied at the top. We got elements defined, nodes located. Anything else? K. Well, K involves what? A, E, and L. We define E, we define A. L is defined by the length. So that's already there. I think we're ready to solve this thing. Click on solve. So we're under solution. Click on solve. And current LS. I'll say review if you'd like, and I say nah. Okay, to start the solution. That should be done within a second. By the way, just kind of as you guys do, if you guys run into problems and it doesn't make sense from the box that pops up right behind this, there's a box that kind of gives the stuff that's happened behind the scenes. That's why it's behind it. So really what you have here is a GUI, and a very old school GUI, graphical user interface. This is really what's happening behind the scenes. So if you have problems, this will sometimes give you additional information that'll say, oh, okay, I realized what I did. So just FYI, it's just right behind it. It's hidden behind it. Yep. All right, let's post-process. All right, because Daniel wasn't happy with the result here. He wants to see the deformed shape. So let's go to general post-proc. All right, it's not a kernel, it's the general. General post-proc. We're going to go to plot results. Oh, we should save DB, by the way. General post-proc. We're going to plot results. I already said that. We're going to plot the deformed shape. All right. The deformed shape only would be kind of boring. We want to see it compared to its undeformed shape. So we'll go with the second option there. And we'll click on OK. And now you can see how it's deformed compared to the original case. All right. If this is a complete shock to you, we might have to have a conversation with Mike McGill. And you later. All right, so you guys don't want just a picture. I know you guys are highly demanding. You guys want numbers. You want data. So let's go skip the plot stuff and let's actually list results. So the next option down is list results. And we'll go to nodal solution, degrees of freedom solution, DOF. And that'll expand out here. We'll do the displacement vector sum. Click on that guy and hit OK. And there's your data for you data people. All right, so you got U and the X, U and the Y, U and the Z. And you find out the You some? Some of you are here, some of you aren't. All right, so we got the displacement. So at 1, there's no displacements. At 3, there's no displacements. Oh my goodness, what happened to our model? 1 and 3 did not move. Oh, we fixed them. Okay, so that's a good thing. All right. We got 1 or 2 being displaced slightly there. Actually, probably the most. All right, at least in the x direction, 0.3, negative 0.3. And we see some displacement by 4 and 5. All right, and then we have some maximum absolute values down here. All right, but this is typically what you're going to be interested in right here. All right, as the final interest or values of your solution. Yeah. Yeah, so let me highlight this again. So you guys had displacements there. I'll show you one other thing here. But let me close that. So seen a couple like draw over several elements being created. When you go into plot and you hit replot, if you don't see your elements and you're pretty sure you drew them, click on elements under plot, and that'll show your elements. The other thing you can do is also go under list and look under list elements, and you say, hey, if I see elements here and they're not in my picture over here, what's going on? All right, so just heads up with that. And actually, do I have an extra one? 1, 2, 3, 4, 5, 7. Okay, that's because I deleted it and I came back. All right, so again, hopefully this will be on the video. It'll be a super long video. Apologize for that, but it'll be a video nonetheless. It'll be my second video, and it'll be public, I promise. What's that? Yes. Yeah, I thought it was, and then I did something happen, and then it turned private. All right, so let's go element table. We'll look at some information specifically about the elements. Let's see what the elements are doing. So go to the element table. This is still under General PostProc. So General PostProc, element table. And we need to go under to define the table, what do we want in our table? So we're going to click define table. Bring up this big old box. We're going to add. All right, we're going to add some data to it. And I'll just put in head 0 here for the first one. The second one, this is just a label. So we're going to say the axial force, so AX force that we have. We're going to do this by sequence number. Sequence number is the last option in this first box. So click down here. And what this is within ANSYS, it says, okay, when I go and do calculations, what calculation do you want me to do? And we're saying, do this calculation. And so by saying by sequence number and then SMIS, which I believe is stress, miscellaneous stresses, we're going to say, do the number 1, right? And that's the axial stress. All right. So we have by sequence number, SMISC, and add a 1 there. And hit apply. For the second one, what we're going to look at is the, what did I do? Oh, that was force, sorry. Did I say axial stress? I think I did. That's the axial force. The next one we're going to look at is AX stress. All right, and again, by sequence number. And instead of SMISC, it's going to be LS. And that's, again, number 1 there. All right. Again, if you check out the help menu, it'll kind of help you understand. That's why it says help. Some of these things a little bit better, like where they're located and which values if you want. But those are the two we're really going to use in this class. So click OK. All right, so you can see here that here's the SMISC and the LS that you selected. We got force and stress that show up. And go ahead and close that window, so those have been defined. And now we'll go to the element table. And instead of define, we're going to plot our element table. And items to be plotted, we're going to do force first. We'll just leave it as, don't worry about averaging. And click OK. All right, so you get nice little pretty colors here of the forces. All right, based on the legend down here at the bottom. All right, so anything that looks like it's green and closer in the blue spectrum is under compression. And the other way is under tension. All right, but again, you guys like data. You want to see the numbers behind all these things. So instead of plot element table, you want to list the element table. So click on list element table there on the left-hand side. And let's do both force and stress. Just click on both. Get them both highlighted. And go ahead and click on OK. And there you go. For each element, gives you the axial force and the axial stress. Negative being compression, positive being tension for each of those items. Again, you don't quite find solace in the fact that you have stress and axial forces. You want to see reaction forces. All right, let's check the reaction forces. So under list results, we'll go back up here and look under list results. So instead of being under the element table where we were before, let's go to list results and look at the reaction salute. All right, reaction salute under list results. And go ahead and go with all items. Click OK. And there we can see that only nodes 1 and node 3 have reaction forces for us at 1500 at 1 and negative 1500 and 1000 at 3.